What's up, fellas? I got some high temperature chemistry coming up and we need to run a burner, and I thought it'd be a good idea to get this compressor going for the job. This thing keeps dying on me and I think it has a fuel delivery issue. So it dies on me after it's been running for a little while, and I think that the cup fills up with gas slowly, and then it lets you start it up and it runs for a minute, and then once you drain the float cup, it dies on you. So that's my mission today, is get this thing running so it can run a burner. So if you guys got any input on fixing an air compressor that it runs intermittently, dies, then you gotta let it sit for 10 minutes, then it starts again. That's kind of what this video is about. This is a Predator 212cc Predator engine. Okay, I got the emulsion tube out. It didn't appear to have anything clogging it up. The jet's clear. So I think it's a filter in the gas tank. It's making it hard for this thing to fill up. It did have a little crud in here, bottom of the bowl. See that sludge there? And there's a lot of this stuff in the gas tank, so I think that stuff has clogged up the gas tank. So we're gonna focus on that. Everything else on this seems okay. All right, I wish I would have took this out before I sprayed it out. I sprayed it out with some contact cleaner, but nonetheless, I've noticed that when the tank is low, it has a very low flow rate. Like the fuel barely drips out of the tank. I'm half tempted to do another demonstration just to show you, but I don't think I want to bother. So I think what we need to do is cut this screen off here. I hate to say it, a serious injustice here. I'd almost rather have an inline filter somehow. Also, I'd like you to notice the position of that hole. It's pretty high up in there. So when you've got this much gas in the tank, you're effectively empty. So you're not getting the full capacity, that's for sure. And then a little after that, this dart goes up in there. So when you've got gas in there this far, it's empty. Might as well call it empty, anything under this line, you know, because it wasn't flowing at all. So I don't know if I got a screen to put in here or not, but we're cutting this off. This is what's killing me, I think. Okay, so another problem I might have found is this gas cap's clogged up with something. There's a bunch of junk in there. This little hole is completely clogged up, and this thing has to breathe to allow air to replace the fuel. I'm gonna drill this hole out. There's a bunch of sand flying out of this thing on me when I'm blowing it out, and I'm wondering if this is from me sandblasting or something. All right, so I think they intentionally packed this thing with activated carbon. I don't know why, but that's where all that black stuff is coming from. That's inside the engine fuel tank. Yeah, they packed the gas cap with activated carbon, so you can't smell gas coming out of it, maybe. I don't know why they would do that. But I'm pretty sure that carbon is what fouled this up. I don't know for 100%, but I think I'm on to something here. This stuff, the vibration from the engine was causing this stuff to trickle into the engine. I had all kinds of black stuff in the bottom of my tank and inside the bottom of the fuel cup. So it appears that the gas cap is the culprit. So let's drill a big hole in the side of this thing, get that crap out of there. All right, so there you have it, guys. The Predator Engine Company, in their grand wisdom, took it upon themselves to pack this cap full of carbon, and it was leaking out of this little hole right here. The hole was that big initially. I drilled it out trying to figure out what was going on, and this black powdery material clogged up my screen, filled the bottom of my tank with sludge. So that's a very interesting failure mode right there. The failure mode was restricted fuel flow. So you guys tell me, you think this is what caused that? I do. I'm almost positive that's why this got clogged up. It already struggled to flow properly. Oh yeah, I know it is, because dust was coming out of this hole right here when I was spraying the hole for testing. I was getting sandblasted by the material coming out where this chain is right here. So yeah, we were dumping black powder directly into the fuel tank using a classifier Insane failure mode. Product design failure. Product design fault. This is a huge fault. What if we were out in Alaska right now? So there you go, guys. If I were you, I'd go get a drill right now and get this crap out of my gas cap if you've got one of these big beefy gas caps. It's falling out of the hole where the latch chain is into your gas tank and is eventually going to clog this little filter up. When I first got the air compressor, I went ahead and tested it out with the 4.5-inch pulley that we have on there now. And at about 99 PSIs, we were getting 8 cubic foot per minute. All right, fellas, so you might want to check out that other video. I'll try and get a link in the description of the first time I overclocked this thing. It's a pretty interesting day. So we started right up, one pole, that's a good sign. Hopefully this thing stays running. As I said, it would always run, but it would die after a little while. So we just got to beat 8 cubic foot per minute at about 100 PSIs, and we're going to be gold. So it's charging up now. We'll take a look in a second and see what it does. Okay, so this was supposed to be a 3-hour tour, as usual. All right, fellas, so it ran so well, I went ahead and put the big pulley back on there, as you can see. And it turned out it's just too gnarly, man. It's too much. This engine isn't jetted for this. It needs more fuel. It's running itself out of gas with the throttle being set as high as I have it. You can see there we are pegging the flow gauge. We're above 11 cubic foot per minute. So the flow is huge, but it's just not sustainable. It's just too much on this thing. We're looking at about 55, 60, 65 PSIs there at 11 cubic foot per minute. Wow, it's clogging down big time. Holding that 100 PSIs. That ain't cool, bro. So as the pressure goes above 100 PSIs or so, it just dies on us. Okay, so I turned the throttle way up to a point where this thing is just going to rattle itself apart. We're at right around 100 PSIs, real close. I would call that 99, I guess, and we were at 8 cubic foot per minute, and now we're at 9.75 cubic foot per minute. And I've just adjusted it again there. The pressure's going up pretty quick. I think I turned the air off. That's what I did. Just about dies. I think the belt's still slipping a bit. I'm going to try to tighten that up some. 5 years ago when I tried this, the engine was actually throwing pulleys. It was waddling out the shaft and throwing the pulley off the engine. So it's even hard to start with this poor of a gear ratio. It's just too high RPM for the forces involved. And to get it to run, I have this engine throttled up so high, you can see that it's going to tear itself up. Look at that engine wobbling on the frame. I don't know if I mentioned it or not, but this is not the original compressor. As you can see, I have extended the deck by about 8 inches there. The initial deck is right where that little round section is, and that's where the pressure gauge used to be. So this is a different air compressor altogether. It did not come with this system. I have just, I threw another $500 at this thing by adding that bigger compressor, hoping to get more performance out of it. And as you can tell by that engine getting ready to rip itself right off the frame. Oh, this pulley is just too gnarly. I'm running out of gas. The cup's being drained at this high of a throttle. And I think the only solution is to have a larger cup jet. Kind of sucks. This thing has to run with like half the choke on too. Yeah. I might put that other pulley back on there. All right, so I put the other pulley back on there to give us a little bit more torque, and we are pushing about 120 PSIs at a little over 8 cubic foot per minute. So we have observed a performance increase from the last time. Not by too much, but it's there. We have about 72 hours on this machine. Running now. All right, so we did get the compressor fixed, but I'm not impressed with the performance gains. Kind of wondering if I should just throw that old one back on there. I feel like that compressor is more suitable for higher pressures. It's got that huge wheel on there. It'd be good for running at low RPMs, maybe if you wanted to run an impact at 180 PSIs or something. I don't know if it would do that with the current setup, but it has a double belt on there, indicating that it is made for a little bit more horsepower being given to it. So I think, well, I don't know. The bigger pulley kind of throws it out the window. I think the engine isn't set up very well. You got to run it on half choke all the time to get it to run. It seems to starve itself out of fuel if you try to turn it all the way up. When you got that big pulley on there, it seems to run itself out of fuel when you have the big pulley on there, period. So I don't know. I don't think the engine is jetted properly for what I'm trying to do to it. I'm just asking too much once again. So one thing we're going to have to check out is, I believe this copper coil might be inhibiting performance a little bit. Look how big the hose is on this side, and then we go down to this little tiny tube. I don't know if that's slowing it down any. I kind of made that coil really long to cool off the air a little bit. I'm thinking about taking some of that coil out of the line. Tell me what you guys think about this cooling coil. I think it's too big. I think we ought to try it with a huge amount of that taken out of there. I don't know. I don't understand why we're getting minimal performance increase when the pistons are so much bigger. And I know you would say the RPMs, but it doesn't have the power to do much more RPMs than this. So how is the other one doing it? I think it has smaller pistons. The smaller pistons would enable it to operate easier at higher pressure, you know? Maybe there's something going on there. Something freaking weird's happening. Okay, took that much coil out of it. Hopefully that doesn't get too hot. Let's give it a shot here. That's about where it was earlier. Okay, I don't know if you can see it. It's pretty dark in here. I straightened out the piece of copper pipe that I removed, and it's over 4 foot long. So taking this off alone increased the performance drastically. I had it on there for the purpose of cooling it off the air a little bit so it doesn't burn up the O-rings in the unloader. But I believe it gave us a significant performance increase. I got a lot of feedback on that first one, and this guy here I know is an engineer, And he's talking about shortening up the length and diameter. I couldn't increase the diameter out on that. This is a very old video, 5 years ago, the same air compressor. Yeah, that was the first time we ever messed with it. And that's what we got off of it. So anyway, there you have it. I think we definitely got a performance increase off of taking that copper pipe out of there.